So this is forming and solving more complex word problems. So again, it's the same principles that we've been looking at in the last couple of lessons, but in this case, they're just a little bit more complex. But again, the process is exactly the same. So we need to be able to take this word problem here, and we need to be able to turn it into an algebra expression, and then we need to be able to solve it. So if we read it, okay, so it reads as, if I multiply a number by 3 and then subtract 4, the result is the same as twice the number. So again, what we're gonna end up with an algebra term that's on either side of the equal sign. So the first thing we do is we let x be equal to the number. Okay, so let's say if I start off and I say x is the number. So if I multiply the number by 3, so if I multiply this number by 3, what's that going to look like? It's going to be 3x. So remember, 3x means I take 3 and I'm multiplying it by the value of x. So the number is, so if I multiply a number by 3, if the number is x, and then multiplying it by 3 would be 3x. And then subtract 4 from the number. So I multiply the number by 3 and then I subtract 4, so that's going to be minus 4. The result is the same as, okay, so the result of all of this, so getting my number, multiplying it by 3 and then subtracting 4 from it, is the same as twice the number. Okay, so then we can say that all of this here is equal to twice the number. Okay, so if the number is x, then twice the number is going to be 2x. Let me just write this out here. So this is kind of like what it would look like. So now we can see that we have an algebra expression. So again, if we read this, so if I multiply a number, okay, so if I multiply a number by 3 and then subtract 4, the result is the same as, twice the number. And what we've done is we've represented that here. So so the number is x, so if I multiply it by 3, that's 3x, then subtract 4, that would be minus 4. The result is the same as is the equal sign, twice the number. Okay, the number is x and then 2x. So now we have an algebra expression and we have an x term on either side. So now what we can do is we can start to solve this and figure out what the actual number is. So what we want to do is, because we have an x on the right, 2x on the right hand side, we want to bring this over to the left hand side. So in order to get rid of it on the right hand side, I have the minus 2x. And if I minus 2x on the right hand side, I have the minus 2x on the left hand side as well. So minus 2x. And so if we do this then, so 3x minus 2x is just going to leave me with x minus 4 is equal to, so 2x minus 2x will just leave me with 0. So now I'm left with x minus 4 is equal to 0. And now what I can do is I can just get rid of the 4 on this side. So if I'm on minus 4, I want to get rid of that. I have to do the opposite of subtraction, which is addition. So I have to add 4. And if I add 4 on the left hand side, I have to add 4 on the right hand side as well. So what's going to happen is these will cancel out, and then x is going to be equal to 4. Okay, so that's what it looks like. So that's really it. So this is just forming more, forming and solving more complex word problems. So again, this is more complex in that, we're ending up with an algebra expression that has x terms on both sides. So that's an example of how to, so again we do exactly the same things. We let the number be x, we write everything else in terms of x that it mentions in the word problem, which is this sentence here. Then once we have our algebra expression wrote out, we can then solve it and then work out what the value of x is. So that is forming and solving more complex word problems.